I want to go over some questions that I anticipate some of you may have at this point. And if you don't have any questions, feel free to skip to the next video where we will begin building out the tipping calculator. Here are the questions that I'm going to go over. Remember, you could always post something in the comments and I'll get back to you pretty quickly. Why are we using repl.it? The reason we're using repl.it is because I wanted to get you up and running as quickly as possible without having to worry about installing anything or maybe having any issues if you're installing something on a Windows machine versus a Mac. The alternative would have been to teach you how to install a code editor, and then teach you how to install Node.js, and then explain to you how to use the terminal or the command prompt in Windows. It's not overly difficult, but it would have been a few extra steps which I wanted to avoid for beginners or someone just learning how to code for the first time. I do plan on going over all of these things when we get into more advanced programming, but for now we're going to use repl.it to remove that complexity. Personally, I like to use Microsoft's Visual Studio Code, which is a free text editor or code editor, but I used to use Sublime and some people like to use Atom. Why did we click on HTML, CSS, JS on repl.it instead of JavaScript? The reason for that is that I wanted to simulate a website inside of the browser and the development environment for a website inside of the browser at the same time. And I wanted to do this because I'm going to use some functionality that browsers have built in that actually doesn't belong to JavaScript. So let me show you an example of this. Here's a brand new website that I created with repl.it. If I go into my script file and I type in alert with parentheses, and then in the parentheses I type in hi, and I run it, you'll notice that a pop-up window comes up that says hi. Now this looks like JavaScript, but it's actually a built-in browser function, and all of the browsers have this. So if I was to use alert outside of the browser, JavaScript actually doesn't know what alert is. I'm going to use similar non-JavaScript functionality to be able to get in an input from a user. Do we always need to write our JavaScript in a script.js file? The answer is no. We actually could have written the JavaScript inside of the HTML file. We could remove this, and this HTML tag script tells the browser that whatever's inside of here, whatever's enclosed, is actually JavaScript. So I could do a console.log right here and type in hi, and when I run it in the console, we're going to see hi. So I could write all of my JavaScript in here. But the reason we use an external JavaScript file is to keep our HTML separate from our JavaScript. We don't want to mix languages, really. What else are we going to learn to build? I plan on teaching you how to build a coin flip simulator, a number guessing game, a bank account app, which is going to be a little bit more intermediate, a weather app, which is going to be advanced, and lastly, we're going to create a password encryption app, which is going to be the most advanced app we'll create. I like using real-world projects that you can then use and share with your friends to learn JavaScript and learn how to code and learn how to think like a programmer. So make sure that you don't skip videos to make sure that you have a good foundation to build on. Why do we use the console to display things? In the first video of this series, I had Dave, who's a professional JavaScript programmer, kind of explain why he uses console and why it's so important. Because back in the day, years ago, the console didn't exist. So whenever JavaScript programmers wanted to see like the value of a variable, they had to use another way to display things. I can show you what that would look like. Let's say, for example, that a programmer created a random number, let's call it rand_num, and set it equal to a whole bunch of numbers. And then they did some stuff and manipulated it. So they did rand_num, and they set it equal to rand_num times 2. And then later on, the programmer wanted to see what the value of rand_num was set to. Back in the day, they might have had to keep track of a lot of variables, maybe on paper on the side on their desk, and do all the math as the computer was doing it. Or they could have done something different, which is use a document.write and then display rand_num on the actual website. So this is what Dave was mentioning in that first video. Back in the day, programmers had to actually put the value of variables in the website as they were testing their code. So if I run this, you'll see that it runs the code and actually displays it on our website. But we want to do things behind the scenes. We don't want to have to create spaces in our website where we can test variables and all that stuff. So what they decided to do was create a console which works behind the scenes so that we can do the same thing but keep it private, so just in case we forget to hide it later on, none of the users will see this. Are there other ways we could have written the code we have so far? I've gone back to the code that we created in our second episode, and I actually just want to go over how we could have written this a little bit differently. You'll notice that we never actually changed the value of any of these variables, so all of these vars should actually be constants. So if I run our code, it's still going to run exactly how it did before. You'll also notice that on lines 12 through 15, I added the name to the string that says, "Hi there, what are you doing? Let's grab lunch, or we can get pizza." But there is another way to do the same thing. And as I mentioned in the previous video, JavaScript was updated in 2015, and they added this new way of writing strings called template strings. So for example, in my console.log, instead of having the name or the variable plus the text that I want to do, I can actually use a template string, which is using backticks instead of quotes. And then using a $sign with opening and closing curly braces right after, I can insert the variable name inside. Then I could write the rest of the string without using a plus sign or quotes. So you'll see that the functionality from line 15 is now included in one string or template string on line 13. And if I run it, it will still run the same way. We should see Mike says hi there 2 times. And actually I forgot my period there, so let me just add it. And there we go. Now it looks exactly the same. What do variable declarations look like in other languages? In C++, instead of using the keyword var, we actually use a keyword that tells us exactly what the data type of the variable will be. So for example, if I'm going to have a whole number, that's going to be an integer. So we use int, and then we can write the identifier right after that keyword. Or if I'm going to have a number with a decimal, I might use a float. So you'll notice here on line 2, we have float my number, and my number is the identifier, and right now both of these are declared but not initialized. And if we scroll down just a little bit, we can see that on lines 9 and 10, we declared A, B, and result as integers. And then a little further down on lines 13 through 16, all of these values are initialized, or they're modified. In C++, variables can also be initialized with one equal sign, just like in JavaScript. In Swift, the programming language used to create iOS and macOS apps, variables are declared pretty similar to JavaScript. So we always use var as the keyword and then the variable name, but we use a colon and write down the type of the variable. So if you have a string, you have to add string right there. And then you can initialize the variable. If you leave out the type, Swift is going to try its best to figure out what the type is, but it could lead to errors in the future. It's actually funny because in Swift, you declare all your variables with var, and you declare your constants with let, which is a bit different than in JavaScript. In JavaScript, let and var work almost the same way, and we use const to declare constants in JavaScript. What happens if we divide 0 by 0 or 10 by 0? That's actually a good question. Let's find out. Let's create a variable and call it banana, and set it equal to 0 divided by 0. And then let's console.log what banana's value is. And if I run this, we get NaN, which means not a number. So 0 divided by 0 is not a number. Let me just add a 1 in front of that 0 so we can try 10 divided by 0, and we get infinity. So that's pretty interesting. So we get infinity when we do 10 divided by 0, and we get not a number when we do 0 divided by 0. Hey Siri, what's 0 divided by 0?
Imagine that you have 0 cookies, and you split them evenly among 0 friends. How many cookies does each person get? See, it doesn't make sense. And Cookie Monster is sad that there are no cookies. And you are sad that you have no friends.
Ouch, baby. Very ouch.
And that's going to do it for this video. I will see you in the next one.